Okay, a quick revision on waves, right? So the front part is all the definitions as usual. What are waves? You need to know. Again, memorize definitions. Wave motion, especially wave motion. This is probably along wavefront the worst to remember. Okay, if you fill in the blanks, it's easy. Okay, you would say, all right, wave motion is the disturbance in a medium that causes the transfer of energy from one point of a medium to another, the same medium. Okay, the disturbance is caused by vibration of the particles in the medium in a specific direction, and there is no net transfer of the medium itself. Very difficult to remember. Okay, you have to put in some effort. This comes out O-level before, where they ask you to define wave motion. You probably can't do it. Two definitions that are hardest to remember. One, wave motion. Two, wavefront. Okay, these two. The easiest, which you are the best in remembering, fortunately, is transverse wave, longitudinal wave. Okay, just have to remind you. Of course, you remember the key term here is perpendicular, right? For transverse wave. Remember, this is vibration of its particles. Okay, don't forget this part. Some people just say to the vibration, but I like you to say vibration of particles. Okay, why do we memorize definitions like transverse wave, longitudinal wave? Okay, sometimes they don't ask you define, but they are extremely useful, and you know the definition when you are asked to explain. So they might ask you, explain what type of wave is this. So when you are asked these kind of questions, you use the definition to help explain. Okay, so that's where it's so useful. Right, so transverse wave examples, any member of EM spectrum, light, okay, ultrasound, radio, okay, plenty, right? For longitudinal wave, say sound, right? Sound is the very best example. Okay, don't say spring. Okay, spring can be either one of them because it depends what you do the spring. Okay, how the action is like. Okay, so here are your definition. Remember. Description of waves, okay, all of you by now definitely know how to count waves, okay? And when you draw nicely, okay, one wave, two wave, right? As you draw three waves, just have to pay attention to the displacement distance, okay? Look at the axis, if it's distance or it's time, watch out. Because when they ask you for wavelength, you will be looking at the displacement distance graph. So you'll be looking for this one. If it's period, then you'll be looking for this one. So be careful, don't look at this one for period, you can't because this is distance. Okay, so take note of the axis. Right, then here is the calculation bit. Here is where you definitely want to score marks if they ask you calculate amplitude, wavelength, period. Okay, as every one of them, okay, goes, okay, there's a simple meaning. Like for amplitude, I told you is a height of a wave. For wavelength, length of a wave. For period, time for one wave. For frequency, number of waves in 1 second. Okay, and speed, how fast the wave go. Okay, so all these simple definition you definitely know. But the main thing, okay, I want you to remember the proper definition. They ask you define amplitude. You cannot just say the height of the wave. It's not correct. Okay, that's in your mind. You understanding is the height of the wave. Okay, is this height or is this height? Okay, that's amplitude, right? So you have to remember, if asked to define proper definition, maximum displacement of a point from its rest position. That means how far did it vibrate away, the furthest it vibrated away from its rest position, okay, before coming back, right? So remember the proper definitions. Wavelength, don't write that length of a wave. Okay, in your mind, you're thinking length of a wave, but when definition, you got to write the proper term out. So I think you understand this well enough. So most of you should be fine doing calculation questions like this, where they ask you calculate the period, frequency, wavelength. Okay, so you first know all the meaning of this, then get ready to use the two formulas in the chapter. T equals 1 over F and the famous V equals F lambda. Right? So be ready to use them to help solve your question. Okay, you should be able to solve. Okay, anything like this come out, you should be very happy. Then sometimes a little bit harder, they will say, okay, draw a second wave to show position half a period later. Okay, then how do you do that? Just remind you again, right? This is one wave, two wave, three wave, right? So if the wave all move half a period, what will it look like? So it means this peak will go half a period. That means you go half a period down to here. So then this one will shift down to here. So what you have is the wave looks like that, something like that, right? Okay, so everything shifted half a period down. Okay, everything move down, move down, move down. Okay, so you imagine you do that. Okay, again, look at your worksheet. We had quite a few practices on this. Okay, you are not sure, right? Okay, then definition for wavefront, as I said, this is the one which along wave motion usually has the most difficult, greatest difficulty remembering. Okay, what is a wave motion? Okay, so these are wave fronts. Okay, wave fronts. These are wave fronts. So they are wave fronts. Remember, if you want to see how many waves there are, don't count the lines. Count the what? The gaps. 1 gap, 2 gap, 3 gap, 4 gap, 5 gaps. 5 gaps here means there are 5 waves here. Right, so remember that. Then from there, you go and solve. Okay? Then at part C, they ask you to draw a graph, remember the label axis, label important information. But you should be able to do it within, if you can remember. Okay? Okay, so the ripple tank, you don't need to know how to draw the setup anymore. Okay, but basically you just have to remember to create plane waves. Well, plane waves are not aeroplane. Okay, the waves are like that. Okay, you want to create straight line waves like this. Okay, what do? Vibrate a horizontal bar at the surface of the water. Okay, then you want to create circular waves like that. Okay, by the way, one circle, the next circle, that's your wavelength. You vibrate a what? A pointed object, right? So all this is just very simple. Okay, that's all you need to know. Okay, you just remember when you ask to draw circular waves, use a pencil and a compass. Okay, draw as accurately as you can. Okay, don't do it freehand. Okay, so that's it for this chapter. Okay, I've gone through it very fast, but what do you need to do? You need to practice. So you get used to all kinds of questions, whether they're asking you to draw the wave, okay, just give you information and you get calculation from there, okay, or wavefront questions. The rest, okay, is just all about practicing, okay, going through what you've done, looking at the mistakes you made, okay, and tell yourself, okay, don't be careless. Usually it's just careless, and also look at the right things that you did a lot. Okay, so it's a very quick revision on waves.